everyone, and welcome to our November webinar. We'll give folks just a minute or two to join us and to trickle in. In the meantime, I would love to learn where everyone is calling in from. I am in the San Francisco Bay Area right now. I know we have our presenters and panelists joining us from all over the Bay Area, North Carolina. We have some folks in Germany. So if you want to pop in the chat where you're calling in from, we would love to say hello. Kimberly, great to see that you're up there in Seattle. Amsterdam, I always love the global group that we're able to pull together for these sessions. See some folks calling in from Spain and Canada. Hello, everyone, and welcome. So this is November's webinar. It's hard to believe that the year is almost over. And today we are going to be diving into upcycling and side streams. This is an important topic. We have been hearing more and more about this across the all protein industry. And we will be digging into this with a presentation and then a panel discussion. Before we begin, I do just have a few housekeeping items. First of all, for those of you that might be new to the work of the Good Food Institute, we are an international nonprofit. We function as a think tank that's developing the roadmap for sustainable, secure, and just protein supply. So we identify the most effective solutions, we mobilize resources and talent, and we empower our partners really across the food system to make all proteins accessible, affordable, and of course, delicious. I also want to make sure you all know that this seminar is being recorded. We will post this to our YouTube channel. We will also be emailing all of you a copy of the recording as well as the slides that we are reviewing today. So don't worry if you missed something. If you have to step away for a moment, you can come back and revisit all of this amazing content. And then last but not least, if you could please ask your questions in the Q&A box versus the chat. That just really helps us keep track of them. You can ask questions throughout the seminar. We'll see if we can get to them. If not, we do have an hour and a half allocated for these talks. So we should have plenty of time to dig into Q&A if you have questions for any of our presenters or panelists. So with that, it is my pleasure to introduce Arpad Casey, who is with Gaia, and he will be presenting on opportunities in upcycling and valorization of alternative proteins, looking at lessons from the brewing industry. So welcome, Arpad. We're delighted to have you, and I will let you take it from here.
Hi, Audrey. Thank you for the introduction. Hello, everybody. I see we have a global audience, so very excited to be here and to talk about valorization and upcycling and alternative proteins and introduce to you our company. Let me pull up the slides here. And just please let me know if you can see it.
Looks great.
Looks good?
Looks good.
Fantastic. Okay, so today's topic, new food for thought in the sustainable development of alternative proteins. So we will be talking about upcycling, valorization, and examples from industry. A little bit about me. My name is Arpad Chai. I'm heading Gaia's alternative protein business in North America, that's US and Canada. And we look after several different applications and business streams, including precision fermentation, plant-based food, beverage, intermediaries, and cultivated meat. I'll talk a little bit about that on the next slide. I'm based in Charlotte, North Carolina. I've been with Gaia for a couple of years. I've been in my current function for over a year, and I have about 20 years of experience in various industries, including food, beverage, biotech, chemical, cement, and steel industries. So with that, there's was my information. If you want to connect me with on LinkedIn or shoot me an email, I included my QR code on the previous slide, and it's also at the last slide. And as Audrey said, we'll share the slides after the meeting. So, feel free to get in touch with me, or if you have any questions and you want to ask in person, I'm happy to take time to answer it. So I'm heading GEA's new food business, which is to us means alternative proteins. That's just kind of the name we gave it. And as you can see on the screen, we cover a wide range of applications. And specifically for me, for the past year and a half, cultivated meat, seafood, and precision biomass fermentation were the two areas that I was focused on developing our brand recognition and showcasing what we can do in terms of technology. So GEA, or GEA, as many people in the US know us. GEA we are one of the world's largest suppliers of technology and systems to the food, beverage, and pharmaceutical industries. We have a very, very wide portfolio. We have a lot in pharma applications, in chemical industry, and focus is really food and beverage. So just a couple interesting facts about GEA. So for food, approximately every third chicken nugget is produced using our process equipment. For beverage, every other liter of beer is produced using GEA technology. And for pharma, roughly every quarter liter of human blood for making plasma-derived products is processed using our equipment. What you see on the screen is the lineup we have in our German pilot facility, which is tailored to de-risk and process developed for novel proteins, so cell-based and precision fermentation applications. We have about 18,300 people globally. We are a global company. We are headquartered in Düsseldorf, Germany, and around over 5 billion euro revenue. So as we are talking about upcycling and valorization, I looked up some definitions and put it up here on the screen. So for upcycle is we reuse discarded objects or material in such a way as to create a product of higher quality or value than the original. And for valorize is to enhance or try to enhance the price or value of something. So at least in my presentation here, I will use the terms interchangeably, upcycling and valorization, because in both cases, we are adding value, we are creating value, we are utilizing perhaps a byproduct, a waste stream or waste product, and assigning through a certain process a value to this ingredient. Another definition from the Upcycled Food Association, since we are talking about food and alternative proteins, is upcycled foods use ingredients that otherwise would not have gone to human consumption, are procured and produced in using verifiable supply chains, and have a positive impact on the environment. Next slide here. I took this from Boston Consulting Group's one of their own reports called Closing the Food Waste Gap. As many of you know, over a third of all food produced, around 2.5 billion tons, is wasted each year. That's worth around $230 billion that is wasted every year. And what I have here is a simplified presentation of their report. Is if we imagine we start with 10 million apples, and then throughout the process from farm to table, we will end up with 3.4 million apples that are wasted in the process. And there's just below really a breakdown at where the waste happens. So mostly in production, and then another significant drivers are of course wasted by consumers in distribution and retail, and during storage, handling, and transportation. I wanted to share, and I'm sure, again, many of you are familiar with this, Mormon's ladder, which indicates how much value can be extracted from food that is lost or wasted. And on this ladder or pyramid, the higher you go, the higher the value of the upcycling or the valorization process is. So at the bottom, you have dump as waste, right? Wasting it, just throwing things away. And then there's a certain 4 categories for energy and fertilizers, where we can burn as waste, we can apply to sustainable energy sources, we can produce fertilizers through composting or fermentation. And then up above, we have raw materials for industry, and then animal feed, which many of the different products I will cover have been applied in the past. And at the top of the pyramid is food, which is really processing for human nutrition or using it for human nutrition. And at the very top, there's prevention, right? Preventing food waste. So next, I wanted to give probably the most famous example of upcycling or valorization of an ingredient, which is whey. So whey has been around. We have known about it for thousands of years. It was prescribed some 2,500 years ago by Hippocrates to fight fatigue, prevent infections and disease. And whey has medicinal uses that stretch back for millennia. More recently, in the 17th, 18th centuries, whey was noted as a functional drink and was served in fashionable whey houses and inns. Even though we have known about its health benefits and its nutritional profile for a while, for more recently, the dairy industry has considered, of course, whey as a waste product and more of a nuisance to get rid of. And historically, it's been, of course, dumped in landfills or used as animal feed. Now, in more recent times, we have, of course, through tremendous entrepreneurial efforts and industry collaboration and technological development, we have found many useful and high value add places for whey. It's present in many of the foods we eat, in snacks, in bars, in cereals, in baked goods. It's used in the beverage and juice industries. It's used in nutritional supplements. As many of you know, whey isolates, whey powders for protein powders that you drink to gain weight and or gain muscle and strengthen yourself. There's infant formula, so it's a very big market and high value market for that. It's infant formula, and it's used in pharmaceuticals in the form of tablets. So whey is again one of the more famous examples, and I wanted to speak to now to another ingredient that has been traditionally either discarded into landfills or put as animal feed, and that is brewer spent grain. So brewer spent grain, let me just show you here the production process of beer production. Brewer spent grain along with brewer spent yeast and some other byproducts are recyclable products of the beer industry. And roughly for brewer spent grain makes up about 80% of the total wet weight of the byproducts that comes out of beer production. Now, for the total wet BSG, about 20% is the dry product, the solids that can be separated, and those solids contain many interesting and useful elements and components that can be then isolated and put for other use as input in other industries, high value inputs. Still with brewer spent grain, the market potential. So again, as I mentioned, brewer spent grain makes up the majority of the byproducts in the brewing industry. It's usually sold as animal feed at 30 to 55 euro per ton. And even at these prices, for when you consider total BSG output globally, it's a 1.3 billion US dollar per year industry. So there's huge potential in here. And then some other information on brewer spent grain here. Valorization pathways. So we have there has been identified, of course, the multiple components and what can be drawn out and taken out and upcycled from isolated from brewer spent grain. There's higher value ingredients, there's lower value ingredients. And really when we are trying to and working with our customers and industry partners and trying to find ways to create high value ingredients in the right place. Of course, the economics of the business has to make sense. So it has to be the valorization pathways, the ingredients have to be investigated. And then in addition to that, of course, we have to look at the potential markets of where we could place these ingredients, where are the companies, what are the economics, the financial, the COGS, the OPEX, the CAPEX of spending. So an example or case study from GEA that we have worked on. We worked with AB InBev's Evergreen with our Italian pilot plant and pasta division to scale up their valorization concept to industrial scale. So Evergreen had already developed a breakthrough process to upcycle fiber and protein ingredients from grains. They refer to as safe ingredients. However, the developments were at a small scale. So what we have done together with Evergreen is we have shipped their products and their concept and process and tested and proofed it out at a pilot scale in our facility, where then we were able to produce pasta that is very similar in nutritional profile to whole grain pasta. So this is one example. And I wanted to go in and just give some other examples of what we are doing or we have done together with our customers and industry partners in the brewing industry. Still with the brewing industry, we have upcycled carbon dioxide. So breweries consume a lot of mass of carbohydrate and other feedstocks like barley, hops, nutrients. For every 2,000 ton of feedstock they consume, they'll make roughly half of that in mass of alcohol. And nearly about 1,000 pounds of carbon dioxide is generated for every feedstock ton, which is then vented into the atmosphere. So what we have done is we have process technology and process solutions where we take that waste gas and we clean it up. We basically put it in liquid form, so it's able to be stored, and then it can be introduced as beverage grade carbon dioxide as a base ingredient into the production. So we created a circular loop. We have an example from Europe. This is E.ON, with E.ON, a Swedish energy company that we worked with, where they have partnered with a waste incineration and a sewage treatment plant, and they're utilizing heat pump technology to take the waste streams, the water and the heat from these industrial processes and turn it into energy. So they fuel approximately 8% of the total energy of about 100,000 homes in the area. And then the last example here that I will touch on is effluent upcycling. We have worked with a Greek juice producer, Aspis, and our longtime partner, Pan Marine, where we help them close the cycle on solids waste. So we take their wastewater from the process. A lot of water is used, of course, in the process as they're washing the fruit and for all other of the process steps. And we are separating very efficiently the solids from this waste effluent. And these solids, in turn, this paste that gets created has value as a biofuel or can be pelletized and sold into just the market as a heating element for residential homes. And then my last slide before I wrap up is the challenges of the industry that we see and face. There's 6 I put here. We have more, and our panelists will touch on, and a lot of our conversation will center around this, but it's really around technology development. So creating cost-effective, scalable upcycling methods. It's about cost efficiency, balancing expenses against value of final product, feedstock quality. There's variability in waste inputs that can impact sometimes significantly the performance of the process. Consumer education, what is upcycled ingredients and how we label things, and to create an understanding in our consumer base that upcycled products and ingredients in whatever food items you're purchasing is a positive. It has a clean process that creates it. It has the right nutritional quality. It's safe. Regulatory aspects, regulatory hurdles, navigating regulations can be challenging. Lobbying for public support. A lot of niche industries at the beginning have to be subsidized by government funding. So this is something we have to address if we want to be successful. And then market viability, which is identifying the right markets and correctly gauging consumer acceptance. And I wanted to leave this slide as kind of a lead-in to our panel discussion. That was it from me. Again, there's a QR code to my LinkedIn page. Feel free to connect. Would be happy to chat with you. And again, thank you for the opportunity to Audrey and GFI for being able to present and talk to you about GEA and upcycling.
Well, thank you so much for that great presentation. It was such a wonderful introduction to this topic. I was particularly interested in the CO2 upcycling example that you gave. We're now going to move into the panel discussion portion of our seminar today. So I invite all of our panelists to join us on screen. And just a reminder to everyone in the audience, if you have any questions, please submit those via the Q&A box. We will have lots of time for Q&A probably towards the end of the talk today. So you can go ahead and get those questions shared in the Q&A box. But welcome everyone on the panel. I would love if you could each introduce yourself and provide a brief overview of your company, particularly touching upon how side stream utilization fits into your business. Andrea, maybe you can kick us off here.
Sure thing. I'm Andrea Shane, CTO and one of the co-founders of Hyfé. We're now based in Emeryville. We closed a $9 million seed round in June and moved the company from Chicago to California on the back end of that raise. So I am newly a Californian, enjoying my very first winter outside of the Midwest. And our company is enabling biomanufacturing as an industry. And by that, we mean the use of microbes to do useful things for humanity, whether that's the production of ethanol as a fuel or a chemical precursor, or the production of proteins that reduce our dependence on animal agriculture, or even the production of things like palm oil, which mean we can make it without deforesting the rainforest. Those technologies collectively have huge decarbonization potential, but the problem is that many of them right now are too expensive. And that's, at least in some cases, attributable to the cost of feedstock or the sugar that's used to power those processes. So we are taking a look at feedstock, which is one of the largest levers in the cost equation, and looking to make cheaper, lower carbon sugar to power biomanufacturing. We're doing that by off-taking waste streams from the food industry, specifically in water form, capturing the nutrients in those streams, and then using them to make fermentation feedstock. Those wastewater streams represent a significant financial pain point for the food industry right now. So we are able to charge for offtake, and then we produce fresh water as a byproduct, which we're able to sell back. And those revenue streams ultimately give us a lower cost of production, so we can see through the vision of the company.
Thank you so much for that intro. What you're working on is so fascinating. Thomas, maybe you'd like to go next, introduce yourself and your company.
So my name is Thomas Kurz. I'm one of the founders of ProteinDistillery. We are located in Germany, in the area of Stuttgart. So ProteinDistillery is working in the alternative protein market, and we developed quite a new protein based on microorganisms. So this is an alternative for all the plant-based proteins, and will replace all animal proteins and make the food real, not only vegetarian, but it's possible to make foods vegan. Our protein is a high functional protein, has very good chelation properties like the animal-based proteins, like emulsification properties, like egg, and all the other very good properties of the animal-based proteins. For the production of these proteins, we use only industrial side streams. So we use brewers' spent yeast, and Arpad showed us in his presentation that there's quite a big amount coming from breweries and are only mainly used as feed for animal feed. Yeah. For my personal background, I'm a brewing engineer. I made my PhD at the Technical University in Munich about yeast propagations and yeast modeling. Was a professor for food process engineering for some years in Berlin at Technical University, and had several positions in the industry, in upcycling of food, in alternative proteins and hydrocolloids industry and fermentation industry in the last 20 years.
Thank you, Thomas. You have such an amazing wealth of experience in this. Lucas, I'd love if you could share a bit more about the work that you're doing at GEA around this topic.
Yes, of course. So hi there. Yeah. Thank you very much. First, to the opportunity to be here today with this amazing team. So I'm Lucas Camargo, and my journey in GEA spans more than 7 years right now. Over the last 1.5 years, I'm located in the Center of Competency in the Brewery Technology Systems here in Kitzingen, in Germany, in the south part of Germany. And specifically within the application development team, I'm a part of the technological part, and I play as roles like a business development manager. And my expertise lies in food engineering, backed by a professional master's degree in biochemical process technology. Throughout my career, I've navigated roles in sales, process engineering, project management, and served as a regional product manager by GEA in Latin America, and also provide some commercial support to our North America team within the beverage technology sector. And present, my primary responsibility here is revolve around the spearheading brewery co-products business development, as mentioned, and of course contributing to application development domains. And GEA has a very interesting approach on the waste streams valorization, as explained already by Arpad. And we are one of the unique companies to provide end-to-end process from receipt until the forming, so we can transform the co-products to very valuable protein alternatives and burgers and other products that can fit to the needs from the customer as well. I started my career and more part of this valorization since 2014, when I also had the opportunity outside GEA to found my own startup in that realm. And the core vision revolved around the reposing spent grains and yeasts, mainly from the brewery part, and various fruits and vegetables to make and to craft the granola bars and proteins for external companies. And I'm thrilled to discuss with you and connect with you today. So thanks to have us here.
Thank you, Lucas. I love the range of perspectives you bring to the conversation. And Craig, maybe you can round out our introductions.
Yeah, thanks, Audrey. Craig Johnson, co-founder of Enough. Unlike Andrea, who's having her first winter in California, I'm having another winter here in Glasgow, Scotland. My company is based across two locations in the UK, our headquarters. And recently we've commissioned a large-scale microprotein facility in the south of the Netherlands. So we're a B2B company supplying sustainable protein. So really, in terms of this, conversation, we filed a patent back in 2014, really to look at recycling the main waste stream from the production of mycoprotein. There's a biomass fermentation, but there's a main waste stream. So that process goes through, or that stream goes through a secondary fermentation through to bioethanol and DDGS, animal feed. We're co-located on a cargo facility in Sasfang-Gent in the Netherlands. So our initial plant is for 10,000 tons. We've just secured some funding to double the capacity. So really interested to look at the discussion on the topic we're clearly an example of a fully integrated process. My personal background, chemical engineer, really 3 phases of my career in specialty chemicals, in pharmaceutical development, manufacture, and latterly, in food. But all of these industries, as Arpad demonstrated, have great opportunities for recycling and upcycling. And I'm looking forward to discussing some of the key drivers and some of the the challenges that need to be overcome.
Thank you. And so to dig into some of our questions here, Lucas, I'd love to direct my first one to you, and Thomas, maybe you can chime in on some of this. In the presentation, we heard a bit from Arpad about lessons from the brewing industry. I know you have several projects in that space, Lucas. Thomas, you've been working in the brewing industry for a very long time. So how do you really see this connecting to alternative proteins? What are the challenges and what are the opportunities right now in brewers yeast?
Cool, great question, Audrey. To start and when we analyze the brewing process, we face significantly challenges related to regulatory standard, storage, handling, receipt, and standardization, mainly for the brewery spent yeast. This is due to the diversity of yeast types and strains that lead to the potential traceability issues and inconsistencies, mainly in the quality standards and compliance with regulations. And this is very essential to ensure the safety and quality of these derivative products as alternative protein as well, when we're dealing with this very yeast variation. So during yeast receipt and transportation, we should pay attention to proper storage and correct handling. And this is crucial since yeast is very sensitive to factors like temperature, moisture, humidity, which can impact directly in the viability and the quality. And it's very important to highlight that the lack of standardization can result in a variation in quality standards. So it's fundamental for product acceptance into the market. And moreover, precision in the standardization, identification, and selection of different yeast strengths is crucial to maintain consistency in the final product. So I hope that I could reply your question, but several aspects that makes mainly the brewer spent yeast. Of course, we have the brewer spent grain, the consistency, and the final product. Standardization, receipt, and how we make that according to the standards into the brewery and the processors.
Yes, maybe I can add here some aspects. So yes, you are totally right, Lucas. Thanks for all the info. Standardization is the key word here. Yes, we need maybe a standardized product, and we standardize it for. In our case, we standardize it for functionality, for gel strength, for example, or for emulsification capacity, not for specific chemical composition or biochemical composition, but for the technological impact we can bring to our customers, which is very important for our customers to replace hydrocolloids like methyl cellulose or replace egg protein, for example. And here, it's yes, what we are doing and what we develop is a process which implements all this standardization, because we know that we have different yeast types and different yeast qualities and different storage capacities in the breweries and so on. And this is really the main aspect of development you have to use if you upcycle a stream like a yeast, or every yeast or every stream which is upcycled, that you are able to standardize it, because the qualities will differ in each delivery. That's our experience, and that's what we developed, and that's the prerequisite to have a product like our highly functional protein, for example. Yeah.
Absolutely, thank you for that background and talking about some of the standardization issues. Craig, I'd love to pivot a bit and to ask you a bit more about your partnership with Cargill that you mentioned earlier in your introduction. I find this to be so fascinating and would love if you could share a little bit more about what that partnership looks like, and how did you set up a partnership that worked really well for both players, particularly thinking about Cargill being such a large and established company. How did you go about setting that up?
Thanks, Audrey. It was not an absolute linear journey. So I'll explain a little bit about the background. Here in Europe, there's some good public support in terms of funding and grant availability to encourage bio-based processing and circularity in particular. So there's an organization called CBEJU, so Circular Bio-Based Economy Joint Undertaking. So they have, over the years, funded 2 billion euros across a range of projects, from more traditional research projects through to what they call flagship projects. So these part fund first-of-the-kind biorefineries. So it's interesting what's happening across the globe. Aware of some activities in the US in this space, but certainly that really catalyzed our project. You have to bid into these projects, so it's a highly competitive process, which we successfully won. Actually, we were with another partner, but for different reasons. That partnership fell through, COVID being one of these. And then we came together with Cargill. For any of these types of partnerships, and I think it applies across where you have two partners with different streams, what type of business model would you construct? There's different options. There's a joint venture, there's licensing, but essentially the model we have at Cargill is that it's a co-location model. So Cargill also offer co-location facilities for utilities, feedstocks in the US. It's an ideal situation for us. So we have a glucose feed, so take grain directly from the canal. Cargill convert that to glucose, so it's piped to our facility. And then there we do our fermentation. At the other side of the facility, Cargill have a bio refinery where they make ethanol. So that is a perfect fit. So it wasn't a linear process. We looked at other locations, and I think for all those in the call, I think the location and co-location is really important. So for some streams, maybe higher value streams, you can afford some level of transportation. But I think the co-location is key to that. So really, to summarize, we were catalyzed through this through this grant. We have 9 other partners in addition to Cargill, from end users through academic partners of Wageningen University. So it's a really good collaboration. So these types of projects are very beneficial, and there's others in Europe. There's one in Estonia, which really converts lignocellulose through to sugars, and a range of other projects. So I think some public support to establish first of the kind facilities, I think, is a very important part of the equation.
Thank you, Craig, and great point around the importance of co-location there. I'd love to open up this question to everyone to chime in on, and it's really around that partnership question. Do you think that good partners are critical in using side streams and upcycling? And curious as to how you have gone about setting up effective partnerships in ways that both parties are incentivized.
Sure, I can jump in there. I mean, I think that the simple answer is yes, of course. And co-location is very much on the forefront of our minds as well. That's also very relevant to our business. I was at LanzaTech previously, and they're working with waste gas feedstocks, and you can't put gas on a truck and take it to a secondary fermentation facility. You have to co-locate fermentation technology, and we're working with huge volume, very dilute wastewater streams, and have a similar challenge. If we were to put that wastewater on a truck and take it somewhere, we would be a trucking logistics business rather than a tech business. And on the same side, when we look at offtakes, the use of the feedstocks by biomanufacturing, the way to get cheapest feedstock is to cut out those transportation costs and co-locate fermentation as well. But when you start building not just one, but potentially multiple co-location partnerships are very much at the heart of all of that. And I think it's, almost by definition, one of the kind of central aspects of being a circular economy business is that you need partnerships around that circle, and that the economics and the timelines and the geographies need to line up for all of those. And there is a significant partnership development component to that, and especially when you're working with larger corporates, like Cargill. There's a long business development cycle. These companies move a bit more slowly, and it takes a lot of work to kind of get a project to a point where it's ready for commercial implementation.
Thanks so much, Andrea. Thomas, do you have many partnerships in your business?
Yes, we implement even more partnerships, and we're starting to implement more partnerships now. We started with some partnerships with breweries because we need for our demonstration plant, which we are actually building. It's only a small plant with 200 tons or 300 tons of protein, which we produce starting up end of next year. We have partnerships with breweries just to bring us the biomass, the spent yeast. But we already start for the next development step of our company for a real scaled up production facility with maybe the 10-fold capacity of the demonstration plant. And here we partner up with companies, and we also thinking about co-locating, because it's very important to have the biomass on place and use the biomass, because you want to make, with the upcycling, make the process more sustainable. So if you have more logistics, then you save in sustain with the product itself. So it makes no sense. So it's the co-location. So we are in discussions with quite a lot of companies, and we also want to implement own fermentation processes. And here we go maybe the same way as Greg described it, to use the side streams of the sea source and make fermentation based on sea sources, which are also side streams, and our side streams which coming again from our process, from the protein production, and use this in combination and make building blocks. And that's what we are actually talking with our potential partners here.
Thank you. And shifting directions a bit, I'd love to talk about funding, which is something that, of course, founders and many folks in the alt protein industry are thinking about a lot, especially these days. What lessons do you have for speaking to investors about side stream utilization? Are there common areas of interest, concern? What do you find resonates with the investor community?
I would say right now, interest is very high, but so are expectations. We've raised 11 million to date, which is far less than many of the others on this call, but did our last round in June. And I think the fundraising environment has changed quite a lot in the last year or so. There's, I think right now, a ton of interest in biomanufacturing, a ton of interest in alternative proteins, really looking at those technologies as avenues for reducing our dependence on carbon intensive industries like oil and gas and animal agriculture, but also very much an expectation that these technologies scale quickly and economically. Companies are under a lot of pressure to set aggressive targets, but then, at the same time, keep burn rate low and think big, but act very strategically to stay focused and start generating revenue as early as possible. And we obviously think that valorization of side streams can be a mechanism for making companies more economic, to increase unit margins and ensure that these bioproducts can compete at price parity with incumbents made from oil or animal agriculture, to see through full commercialization and then full decarbonization potential of the industry. But it's not simple to use a side stream. I think right now that we're lacking a lot of data on the market potential and the composition of these side streams. There's a lot of development that goes into getting a side stream with variable composition into a feedstock with consistent composition, which is what you really need if it's going to serve as the foundation for a bioprocess.
Maybe if I'll just come in on that point from Andrea, and then answer the broader point of investment. So we've done a project with Moser Meat, so a cultivated meat company who are part of our EU Plenitude, project. So they were looking at a side stream, one of our side streams for growth, media. And as Andrea said, as well as the kind of techno-economic, challenges, there's also the kind of the variability, challenges. So it's something that in a laboratory you could make work, but when you look at the kind of more detailed, techno-economics and variability factors, it just wasn't something that was wasn't something that was feasible. If I go back to the the fundraising aspect, as all in the call will know, you're looking at the kind of team, the tech, the market, and where the organization is. So that's what you're looking at. I would say that the recycling or upcycling would be part of the the market, or maybe part of also the kind of DNA of the company in terms of sustainability. So all investors are looking at sustainability. Some have that as a core part of their of their portfolio, if maybe green tech investment. Some are perhaps more interested in the broader life cycle analysis. So we work with a very nice Italian company called Life Cycle Engineering as a kind of independent within our consortium to look at life cycle analysis. So I would say it's part of the broader investment pitch. Some companies are will focus more on that, but it needs to be positioned alongside the other more traditional aspects of fundraising.
Thank you, Craig. Thomas, do you have anything to add to this?
I think all important aspects are set. So it's always a mixture of this sustainability and life cycle assessment, and which the funding companies are which is important for the funding partners, and also the scalability, which was a really important aspect. Maybe I can add the IP. So you need a good process, you need the IP. So it should be your own IP, and the scalability is maybe one of the most important aspects. So you have to have a process or a product which is easy to scale, and the legal background, like the government laws, like novel food regulations in Europe, which is a big hurdle, for example, for microorganism-based products. And that's the reason why we use spent yeast as a raw material, and use this side stream and not any other microorganism from fermentation, which we also can use in our process. But it's a very long way to have this product on the market, to go through all this novel food process and things like this. So it's a combination: legal background, novel food regulations, sustainability and scalability.
Those are all excellent points. And
yeah, Audrey, just to add one more point on building on Thomas, I think the kind of scalability aspect's key. You're trying to scale your business, you're also trying to scale potentially the process, and for upcycling, normally would be a demonstration, which would be lab through pilots, some element of demonstrator, then full scale, and these stages lend themselves to inflection points for funding. So they almost naturally come to they're not easy, but they would naturally lend themselves to inflection points as you proceed through the funding cycles.
absolutely. And I guess building on this, would love to talk about TEAs, techno-economic assessments. Have you all completed a TEA? I know that investors often ask for these. And where are you finding, if you have, where are the bottlenecks in terms of making upcycling work?
I can jump in. So yes, we have a TEA. Of course, a TEA is a model, so it's only as good as your inputs. And at an early stage, some of those inputs are still soft, so it becomes more accurate with time as you're able to generate more data and put in firmer inputs into the model. But I would say it was a critical exercise for us in understanding sort of the interdependencies of a lot of factors that play into the economics of our business. For instance, revenue from wastewater offtake, revenue from freshwater return, revenue from feedstock sales, the CapEx and OpEx associated with processing of wastewater streams of different volumes and different concentrations. And then thinking through the composition of that feedstock and what it needs to be in order to have near-term line of sight to a biomanufacturing end market. I think in the fullness of time, this industry is going to become more diversified with respect to feedstock. But right now, everyone uses sugar. And so if we want to start generating revenue on a time scale that ensures our survival as a startup, we're really thinking very focused on sugar right now in a first feedstock product. And all of the clarity of all of that kind of comes through looking at the techno-economic model, because that's where you factor in all of these considerations, and then you get an understanding of which projects are going to be viable for the business.
So we've done detailed TAs, and we've updated that as we've gone through scales from 100 liters up to 200,000 liters that we're currently at. In terms of those on the call, there's providers like GIA that have got lots of kind of benchmark data who are very useful here. I also noticed on the call we have Wolfgang Ram from Desmet Engineering. So there's a range of engineering companies who again can help with that with that process and have benchmark data from elsewhere. Also on the chat, our comms partner, Bridge to Food, is putting in some detail on the Plenitude project, and there's a link there to life cycle engineering. So there's a range of kind of external bodies that can help you with the techno economic analysis. Last week I was in Lisbon at a EIT food event. We're a Rising Star alumni, and there's a range of companies there that were involved in looking at recycling and doing fermentation on waste streams. And when I was speaking to a few of these companies, one was a company called GreenSpot, French company, and one of the key factors, they were looking at tomato waste from the tomato industry, and one of the key factors there was the location. So they've physically located, so that transportation cost and the having available energy and the co-location, I think that's an absolutely key driver, and it's the same for many companies.
Great points. And Andrea, I'd love to just dig into something you mentioned earlier around people's reliance on sugar. What do you think it will take for folks in the industry to move away from those standardized feedstocks? How do you get them to make the leap and change what they're doing there?
Yeah, okay. So I think part of the reason that this industry has sort of landed in this spot of sugar dependency is because biomanufacturing for the production of pharmaceuticals were some of the first kind of success cases in biomanufacturing. And when you're making antibodies or insulin or other sorts of pharmaceuticals, who cares about what the feedstock cost is? You can buy the most expensive feedstocks, you can use pharma grade products, and still end up with very nice margins on the back end. And so I think companies kind of started working from a little bit more of a pharma-based model where you're using expensive CapEx, so stainless steel reactors, you're using high purity inputs, but then trying to do that to produce molecules or end products that perhaps have less margin than pharmaceuticals. In some cases, really high volume commodity scale products. And those are some of the ones that I'm most interested in enabling, because I think that they have the greatest ability to reduce our dependence on carbon intensive industries and have greatest potential carbon impact. But the economics are certainly most challenging. And so ultimately, I think it's going to come down to a decision based on cost. Sustainability, of course, is also a benefit. If you look at wastewater derived sugar compared to crop sugar, there's a significant carbon benefit. But really, I think to have most adoption, we're going to need to compete on economics alone. I also think kind of in the fullness of time, companies will become more diversified, like I said, with respect to feedstock, and we'll start building systems with compatible with more complexity in feedstock, because we can purify and purify and purify, but to do that, we need to add more and more unit operations upstream. And every time we do that, the more expensive the feedstock gets. So we want to purify it standardize it to the point that's necessary, but not beyond that.
Absolutely. And speaking about making this more widespread, question for everyone, what government policies, what regulatory changes would be helpful to all of you in building your businesses? What are those big ecosystem changes that you would love to see to really support some of this side stream utilization, this upcycling, and ensuring that these business models can be more successful? Arpad, I know you had some great thoughts about this in our earlier prep call, so maybe you can kick us off here.
Sure, would love to. Yeah, I think for public support, it will have to come in many different ways and forms. I think importantly, subsidies to the industry, right? So subsidies to the companies who are trying to valorize upscale ingredients, upcycle ingredients will be very important. We talked about in the prep call about Tesla, right? And that they were heavily subsidized during the first part of their existence, I think around 10 years or so. And now they're at a point where they are able to make money and able to make a great product. But if there was no government support behind that, and many other industries like the solar industry, it would have never taken off, or it would have taken much longer time to take off. So I think what we need great lobbying. We need companies like GFI who can really package the message of the startup companies, of industry as a whole, and put it in front of regulators and public policymakers and our senators and congressmen and governors, and to raise awareness of why what we are doing is good, right? It's valuable to in many different ways, and to incentivize it in a way so companies like Andrea's and Thomas's and Craig's can be successful.
Maybe I'll pick on that. We're integrated with a biorefinery, so very simplistically, E10, E15, so the bioethanol kind of requirement within gasoline. That's the kind of very basic driver of parts, some parts of the industry. So there's that type of intervention. I covered earlier, in Europe, and we're seeing it elsewhere, some more funding to get facilities going. I know in Scotland we have quite a bit of whiskey production and whiskey waste. So there are companies there. One of them, Celtic Renewables, are looking at biobutanol from whiskey waste. But rather than subsidy, they're looking at a kind of premium on the product produced. But that can be difficult. So you're looking at premium for it's more like a specialty product. So I think the price premium across the industry will come. We're targeting meat replacement. So in our industry, will always be compared with the price of chicken breast. So perhaps not. It's now the time to get into the subsidies of maybe the more traditional industries, but that's maybe a debate for another time. So I think there's a range of potential interventions, but it's probably a balanced portfolio. I also see we're a B2B company. So we work with a range of customers, and they certainly the larger corporates have very strong sustainability drivers. So there you're looking at the benefits of lower carbon footprint in addition to simple cost competitiveness.
We're also looking for policy and incentives to be technology agnostic, perhaps looking at the carbon impact of these side streams rather than their particular sourcing. Like, for instance, we'll occasionally run into funding opportunities that will specify biological feedstocks like plant matter or sludge from municipal solid waste. So wastewater treatment actually is a biomass fermentation. I didn't even know that at the beginning of time, but that's how the world cleans water, is by feeding all of the organic content in that water to a bunch of microbes who scavenge all of those nutrients, and in doing so clean water, but they also grow and multiply. So at the end of that process, you have a huge volume of microbial biomass that's either incinerated for energy, applied on land as a fertilizer, or typically disposed of in the landfill where it degrades into methane. So there are also some opportunities that focus on valorization of that sludge or the microbial waste byproduct of municipal wastewater treatment. What we're saying is, and wastewater, right? Like the point where it's that stream still has fermentable carbon that can be useful for the broader industry. And so to the extent possible, making that policy and incentive technology agnostic to make sure that novel applications don't slip through the cracks. I would also add that the timeline for these incentives and funding opportunities matters a lot. I mean, if like these decision cycles are months to years long, that is like the birth and the death of a startup. If we have to wait 2 years to get a decision on a regulatory issue or to find out whether we're going to get a grant that is perhaps critical to the strategic planning of our business, I've seen, I was at a conference yesterday and talking to another people who were really struggling for that reason. And I think that the world is going to lose a lot of otherwise promising technologies if the timeline for some of this policy work can't speed up to meet the necessary pace of a venture-backed startup.
A great point on timelines. And speaking of timelines, we do have another 30 minutes. So folks who are joining us, please stick around. I have 2 more questions for our panelists, and then we will be opening it up for all of the Q&A. So please hang out. We have a lot more to cover. My second to last question for all of you is, where do you see additional areas for research? If you had a magic wand and could make research happen in any realm related to upcycling side streams, what would you have people focus on? Lucas, maybe you can kick us off with this one.
Yes, of course. So from our point of view as technology development, I do see that we must to create more cost-effective and, as Thomas said, scalable upcycling methods that could pose challenges and, of course, being effective to the customers. So something that it's really challenging for us and for most of our customers is to look in and to make the extraction, because when we pick up like the example like pre-spent grains, we do have a lot of macro components that are valuable and they are abundant. So how you make that extraction feasible and how you use less energy depends on the area in the world. So like here in Europe, it's extremely high cost, and we are taking care of that, of course, figuring out of the sustainability path. But I do see that we must to create cost-effective most of that extraction from my point of view and what we are experimenting from the customer point of view.
Thank you. Arpad, do you have more to add to that?
Yeah, I wanted to, and it was something also that Andrea said before about the pharma industry and how feedstocks and whatnot in pharma industry, they never had to think beyond because simply the profits. And it's also to tie it into what Lucas said, on the technology side, we see the same things specifically in cultivated meat and seafood, right? That the people who are coming into the industry, having startup companies, they are trying to set up their processes and plans with pharma in mind, as that's what everybody knows, but it's simply not going to work for a commodity product like meat. We have to find and we have to research solutions together with the startup companies on how to optimize the processes, create circularity, reduce waste, minimize hygienic requirements to the point where they can be. And we see this a lot. I mean, there's perfusion technology where they normally do single-use perfusion plastic bins that are extremely expensive in pharmaceutical space. There are companies now where we are working on continuous processing, on continuous stainless steel perfusion, and then also on recovering the media, right? Properly recovering the media, filtering out, removing the inhibitors, adding back in the right ingredients, and then putting it back into the system. And it has to be 100% circular system. So I would like to see more research to echo what Lucas said on the technology side. I think that's going to be important.
Good points. Andrea or Craig, do you have any research wishes?
I do. So I would love to see some more consistency in accounting, carbon accounting frameworks. I think there are a lot of different frameworks right now, but there's not a lot of harmony across industries, across geographies. And it's a difficult exercise in and of itself, much less trying to like navigate the differences between those frameworks. I would also like to see some more analysis. I mean, honestly, what GFI did in that, I was on the plane back last night, I was reading the report on side streams. And it's that sort of thing where you get a little bit more of a bird's eye view of the overall landscape. And I think that that can is of course very useful to us when we're interfacing with investors, consumers, to kind of show how we fit into that landscape. But it's also a really useful way of seeing where the opportunity is and sizing potential markets. I would also love to see more basic science research around the metabolic capabilities and tolerances of different microbes that are commonly used in biomanufacturing. For instance, in wastewater, we have like occasionally sugar heterogeneity. So we'll have both glucose and fructose available. That's not often what companies do, but they're both very usually readily consumed types of sugars, but understanding how microbes perform on those more complex feedstocks, and perhaps even doing genetic engineering to enable, say, like co-metabolism of different sugars.
But I think from my side, we work with Wageningen University, and in this topic, one of the key bedrocks is analytical science. Is having a very good characterization of your process stream and any side stream, and then the product. So there's the nutritional aspects, the digestibility aspects. So these are all things that are there's just a lot of detail that's needed. And I'm seeing in one of the questions about the a good match. There's the variability of side streams. So these are key. And if I had a magic wand, we haven't really talked about the the regulatory environment, in terms of the FDA GRAS or novel foods in Europe. So particularly on impurities, yeah. So there are some maybe historical, standards, and it's very difficult on some side streams to guarantee, zero, impurities. So that whole area of kind of impurities research, novel foods, impact, etc. I would say that's a key area for for academic study.
Okay, so maybe I can add a last point. So for me, as Andrea said, is the co-fermentation is a very important point. So we are in competition with very cheap products on the food market, and we use this upcycled spent brewer's yeast, which is quite a cheap raw material. But it's cheap because it was used for another purpose. So the beer was in the center of the purpose, and the brewers sell the beer, and they have a waste stream, industrial side stream, like the spent yeast or the spent grains at the end, which are then easily available and quite cheap, and you can make a competitive product from it. So we need even more processes like this. So co-fermentations, so make a high value product and get the biomass as a side stream. And here much more research should be done, and we are doing this as good as we can, and we partner up also with universities like the Technical University Munich and Hohenheim in Stuttgart. But there's a lot of work to do in this area.
I love all of these research ideas that we can seed with everyone who's tuning in today. I have a closing question, then we'll turn it over to our audience questions. And mine is really around what advice you have for other startup founders who might be interested in incorporating side stream utilization into their business models. We have a lot of folks who are in the early days of starting companies or thinking about starting companies on this call. So what advice would you give them as they're starting out? Andrea, maybe I'll pick on you to go first.
Sure. And this is going to be a bit self-interested, I fear, but I would encourage people to think carefully about their techno-economics and understand the main drivers there, and then to think thoughtfully and early about how they might be able to make reductions. And feedstock is typically 20 to upwards of 70% of the total operational cost, kind of depending on the product. So it can represent a really significant cost driver. And that's not to say you necessarily have to do that feedstock development yourself, but start thinking about where to start screening feedstocks in your product development cycle. Because if you wait until you're at pilot phase or commercial phase, it's probably going to be a bit late. It's going to be difficult to implement changes at that point, and you could find yourself in a place where it's too risky to make changes on the feedstock side, but without that, your process is not economic. And to help companies like me do that, I think we need companies to be a little bit more transparent in their requirements. So what sort of volumes do they need? What sort of compositions? What sort of geographies will they be operating in? And what sort of volumes will they need? Because that helps us to develop technology in a way that it will be available when those companies reach commercial scale production.
Thank you. Thomas, what advice would you have for other founders?
Okay, so Andrea said the most important thing. So it's you have to be aware what you have as a side stream. So you have to secure the amounts you need in your scale you are. So you need only small amounts in the lab development and the pilot development, but you need bigger. If you are going to TRL 6 or even to 8, but if you are in a real production, you have to secure your supply, and then you have to check the variability of your raw material. Because if you have not only one supplier, but several suppliers, and Lucas told us this right at the beginning of the session, so there's a lot of, for example, in the yeast, there are a lot of different yeasts, but there are also a lot of different spent grains, for example, with totally different composition, maybe in different countries. And you have to be aware what you can get, and you have to adapt your process very early. That's very important, that you talk to your engineering partner, make enough capacities in your machinery, enough flexibility in your process that you get all these things managed. That's very important. Next to all the business aspects, you will have to be aware about your business model and things, but this is maybe clear, yeah.
Great point, and very pertinent to utilizing side streams. Lucas and Arpad, do you have any lessons from all of the work that you've been doing with startups over at Gaia?
I'll give it to Lucas to answer.
Yes, of course. We are working with many startups at the moment, and our experience that they are looking for some sophisticated but simultaneously not a high cost technology, because at the end it's very difficult for startups at the moment to have a capex. So then they are looking for alternative business models that could promote OPEX instead CAPEX. And this is very interesting also for us, because Gaia, for decades, we are just operating that CAPEX model for all others capital sales machinery engineering companies. And to looking for technological part, this is something that we are doing continuously, because we develop, this is our core business, but to deep diving in this new business model that we can switch and do something advanced, such like equipment as a service, or something that we can promote, and to dilute this cost is something that is really intricate, and it's giving us a high challenge at the moment. So this is for me what we are facing as the most challenging stuff at the current stage.
Yeah.
I'll just add to it at the end anyways. from working with startups, in my experience, engage Gale or any engineering company, process engineering company you're planning to work with, engage them at an early stage. So we can look at solutions and the scalability of your technology. Don't just assume that because it's working at lab or benchtop, it will work at industrial scale in a linearly scaled fashion. Oftentimes there's many different parameters and a lot of discussion and development that has to take place. So early engagement is always beneficial.
Yeah, I can give a one add what Arpad said in terms of simulate equipment and process line. Just an example, bioreactors are something that startup and upcycling the stuffs we are using in that field, and is extremely difficult to simulate the upcycling or to scale up bioreactors. So yeah, we have some modelings and to make that in the computers upfront to go and to make any further investment. So yeah, we are paying attention exactly what the customers are looking for.
Do you have any closing advice for any other startup founders out there?
But I would say before I started this journey, I'd never heard of the word beachhead, in terms of your first market. So I've done a bit of training over the years now. And I think for founders, it's, well, what is your beachhead market? Is that with a side stream? Isn't it with a side stream? So you could have different strategies, maybe what your longer term vision with certain economics, but you may not be able to get there initially. So maybe think about what your initial beachhead might be. And where we ended up, you also have to be have a strategy, but be pragmatic. So we're using a different raw material than we thought, because of impurity and other issues. So I think that would be my one word of advice. Think of beachhead versus the side streams that you may use.
Well, thank you for all of the fantastic advice for any future founders out there who are tuning in. We're going to now shift over to some of our audience questions. The first one actually came in during your presentation, Arpad. This person's curious about what happens to the 80% wet residue of brewer's spent grain. And then kind of a follow-up question or a clarifying question is, are you using the dry or the wet residue? Are both suitable? What are your thoughts on that, either Lucas or Arpad?
Okay, I'll answer the first part, and Lucas will answer the second one. So when the solids are separated and the water is the remaining water is basically cleaned and recycled back into the system. So that's the most simplest answer to it. They try to create as much circularity and recovery as possible.
Yeah, so the second part that about the usage of dry or wet, we have both, but typically dry, it's due to the transportation and further costs. Most of our customers and people that are looking for the solutions are looking that dry it. But definitely today we have already looking to make some alternatives using the wet spent grain. So like Thomas said, is not 100%. We need also standardize because geographically the raw material is not the same, the malt's not the same, and yeah, but typically we have both. But primarily companies are looking for dried instead of wet.
Thank you. This next question I think is interesting. So we were chatting about this a bit during one of our prep calls. We're curious about if ingredient buyers are going to pay a premium from upcycled ingredients just because they are more sustainable. How do you think about that cost profile of something that might be more expensive but be more sustainable? I'll open that up for anyone who wants to chime in with a thought.
I'll have a go at that. So it's not really probably upcycling, it's more a broader issue. So we're working with a company looking at substituting microprotein for existing soya protein. So in terms of more the LCA and some of the other aspects associated with soya, that's one example where customers would look for ingredients that are more sustainable. That's a very kind of simple example.
And I would say yes, but only a segment of the potential consumer population. That segment, I think, is really important for early adoption and to generate revenue market traction to enable a company to raise more scale, more eventually produce at larger economies of scale. But I do think ultimately the way to produce, to get the most sustainable products at maximum adoption in the marketplace is to make it not necessarily the most, the sustainable option with the green premium, but to make it the economic decision. I really want to enable products where consumers may be making a decision based on economics alone. Honestly, like most consumers probably don't even understand like the intricacies of sustainability that go into the products that they're consuming. But to make products that are of equivalent or higher performance and are at price parity or cheaper and also more sustainable. That's a tall order, of course.
A very tall order. And switching directions, how do you get breweries, distilleries, your partners to care about your solutions, given that it's not their core business? It's on the fringe of what they might be developing. How do you work with them to get them to care about it in the same way? Because it's obviously critical for your business. It's a bit more optional for their business. So do you have any ideas around licensing, joint ventures? How do you make this effective for both parties?
Yeah. So first of all, it must be a win-win situation for everybody. So for all the partners, and if you have a supplier for raw materials, so it must be also economically a win for them. Or if it's not economically a win, it must be a marketing win. So we have all these CO2 balances, and we have the marketing aspect that we have a sustainable product. So we have a side stream not going to, let's say, cattle or soft feed, but it's maybe valorized in a very much higher level to a very functional protein. And maybe we have say, okay, this product is made with, for example, spent yeast from these breweries. On the other side, they say, okay, we have a certain idea behind our selling of the side stream, and say, okay, we don't want to have too long transport ways, for example. So we have a lot of partners. They say, okay, we want to have a very short transport ways and low transport impact. So that's the idea of how we work with our partners to solve this problem.
Thank you, Thomas. Any other thoughts? All right, we can move along then. Andrea, this next question's for you. Someone's asking if you could speak a bit more as to why sugar is unsustainable and costly, and really how do you tell that story to investors? What data points, what stories really resonate when you're talking about this?
Yeah, that's a great question. I actually think that there are kind of a couple of ways to think about this. The first is perhaps sustainability. And when we say sugar, it's crop sugar traditionally is what's used, and that's sugar that's coming from typically corn in the US, sugarcane or sugar beets in some instances, or in regions like Brazil. In Europe, oftentimes that sugar is coming from wheat. And that crop agriculture, by using crop sugar to power this process, that carbon is kind of within the existing carbon cycle on the face of the earth. So it's better than pulling out fossil carbon to produce similar products that will generate emissions and worsen global warming. But still there's carbon intensity in that agriculture, and then in the production of sugar from those crops. And for precision fermentation, where you're using fermentation, not necessarily produce microbial biomass, but like a specific target protein, there can be, it can be like, I think 20% or more of the total carbon intensity of the process is coming from that sugar alone. And so using waste carbon, which doesn't carry like the carbon allocation of a target crop, can significantly improve the carbon intensity of end bioproducts. Okay, the second way of thinking about it is cost. And so, like I said earlier, feedstock can be like 20 to 70% of a fermentation, the cost of a fermentation process. So even small gains there can have a really significant impact on the overall economics of a project. There's also a wide range of pricing for sugar. So if you are like a big company at commercial scale production, you have sort of the leverage to negotiate long-term bulk contracts and get low pricing. If you are a small or medium-sized manufacturer, you're paying at the upper end. So like the USDA, for instance, I think the most recent pricing for glucose is around $1,500 a ton for small and medium-sized contracts. Larger contracts are available at significantly lower prices, but again, like you have to be one of the big guys to be able to negotiate one of those contracts. And then the last way to think about it, I think, is in terms of supply. And so, you know, the Biden administration has been generating a lot of incentives and putting out a lot of reports around the forecasted growth of the bioeconomy and of biomanufacturing. And we were doing some back of the napkin, back of the envelope, I don't know, maybe those both work, math the other day, and we're trying to figure out how much sugar it would really take to power this industry if this forecasted growth comes true. And it was something like 1/3 of the arable land in the world would need to be planted with crops that are generating sugar. And like, if that happens, and I hope that it happens, because I think that's how this industry is going to have most impact, there are going to be significant supply chain issues, especially in the face of ongoing climate change, where there are there are regions of drought or political instability caused by climate change that affects the supply chain of sugar.
That is a fascinating calculation there around the amount of feedstocks required. This next question, I'm not quite sure if folks will have the answer, but I'll ask it anyway. Someone is processing starch potatoes in the Netherlands, and they have potato juice as a major side stream, lots of amino acids and sugars. They're saying it has a high microbial count, and are curious if that would interfere with biomass generation using an added microorganism. It might be very costly to sterilize this. Do you have any feedback or ideas for this question asker? If not, we can move along.
I can jump in again. So I guess I'm not shocked by this, because if it's a stream that has a lot of sugar, microbes are going to love that. And in producing something like a feedstock, we want to make sure that we don't have like a microbial environmental contamination, because they're going to eat all of the useful sugar before it gets to an end bioprocess. So we have some microbial controls built into our process. Often there's also a sterilization point before that feedstock is introduced into a bioprocess to ensure that those environmental contaminants don't outcompete the target organism.
Thanks for that. And one final question. What will be the first high volume product that uses side streams and waste streams? Any ideas out there amongst our panelists?
Bioethanol is one that already does, so that's not a food product, but that's one. In terms of the food products, it's the high volume food products. So I would pick pea protein, which already recycles various parts of it. I'm not an expert, but I'm sure that I know there are aspects of alternative milk production where side streams are used, and also in many large scale processes, particularly continuous processes, there's quite a lot of integration, be that heat network, integration. So that type of integration as opposed to physical, waste streams. So I would say the answer is in the large volume, processes, and it's easier more economic on larger volume processes.
Thank you. Any other concluding ideas? All right, folks. Well, that wraps up our November seminar. Thank you so much to all of our panelists for joining, everyone in the audience who has been participating in this. We really appreciate all of you, and stay tuned for our final seminar of 2023. That will be December 15th, and we'll be talking about nutrition and product formulation and alternative proteins. So hope to see you there. And again, thank you so much to our panelists for contributing your insights and expertise today, and for you, our pod, for your amazing presentation at the beginning. And we'll be sending out everyone an email so you can get a copy of this. Bye, folks.
Thanks, Audrey.
Thanks, Audrey.
Bye.
Bye, guys.
Bye.
Bye-bye.